This is the simple wireless scenario. We have defined some variable before going towards the real code. Okay, so these variables we have defined because we will use it later. So first variable is set. Set means we are defining something. What? The variable name, value of x. So yesterday we covered this thing also. So set any variable name, then its value. Okay, so the value is 5000 here, and the variable name is val x. You can give any name here, a, b, c, x, y, z, any name you can give. There is no problem in that. But in this file it is given something like this. So value of x is 5000. Why I have given here? You won't know, however, comment is written here, x dimension of the topography. So we are creating a scenario, wireless scenario. We will have to define its length and width, the size of the topography. Okay. So inside that topography only the nodes can be placed. In wired networks, there is no need to define it. Why? Because wired network is connected to other nodes using a separate link. Okay. So, but in wireless network, what happens? The scenario creates a lot of impact. Okay. So that is why here it is very necessary to define the length and width of the topography. So value of x is 5000, value of y is 5000, value of nn. Nn means number of nodes we are taking. We are taking 150. So this how many nodes we are using? 150. Now value of stop, we have given it 200. 200 means it is simulation time. After 200 seconds, the scenario will stop. Simulation will stop. Now value of routing, we have given AODV. Queue type means which type of queuing we are using. Queue, drop tail and priority queue. Okay, priority queue all of you must be knowing already. Okay, so set value of MAC 802_11. MAC 802_11 is what? It is a standard defined for wireless LANs. Okay, so we have written this one here. Now value of antenna, which type of antenna we are using? Antenna oblique omnidirectional antenna. Now which type of propagation model we are using? Okay, value of propagation, which type of propagation model we are using? Two-ray ground model. Okay, all of you must be aware of it. Two-ray ground is there, then Nakagami and some other models are also there. So we are using two-ray ground model. Okay, so MAC layer we are using, in MAC layer we are using the standard for wireless LANs. Antenna we are using omnidirectional antenna. Two-ray ground model we are using. Then physical layer we are using this PHY/wireless PHY. It doesn't make any sense. Means for wireless physical layer we are using, but why we are using this keyword only? Because some file is attached to it using this keyword. Okay, this thing is called actually the TCL hook. I will be telling you what a TCL hook is and how it looks like in the source code. So again the channel type is wireless channel. Okay, you will have to define the same name. This W cannot be small or this E cannot be capital. Okay, IFQ. What is the size of interframe queue? Means how many queue packets can be stored. It is maximum value is 50. Means maximum 50 packets can be stored in the queue. If more than 50 packets are there, the packets start dropping. Okay. So this value is commented. So this is again a queue type only, but this queue type works with one protocol DSR. So you don't worry about it. Just keep it commented. I will tell you if any necessity arrives. Okay, so these things. Now pay attention here. We are defining some integers 5000, 5000, 150 and 200 using the variables. Okay, and we are defining some keywords using the variables. So variable name can be anything. Variable name is upon us what we decide, but this keyword is fixed. You cannot change it. Means you can change it with another keyword that is already there in the source code, but not with a random one. Okay. But these values 5000, 5000, 150, these you can assign anything as you want. Okay, suppose you want to make total number of nodes 50 only, then you make it 50. Okay. So up to here we have only defined variables. Why we are using these variables, how we will use it, that we have not known yet. Okay. So I will tell you as we proceed in the program where these are used. Now compare this program now with the wired scenario program. First line was what? Set NS new simulator. The same line is written here. However, the difference is one underscore is written here. I told you yesterday this underscore is written in for wireless scenarios and only NS is written for wired scenarios. Why it is like that? So that if you copy some other person's code from somewhere, okay, there won't be any error like that. And some other source codes are written in this way also. So that is why it is a common notation. Okay. However, you can make it anything. It won't create any error. Okay. Now set topo. The new thing is here, set topo new topography. Okay. So since it is a wireless scenario, a topo variable we have defined, it defines a new topography. Okay. So the size of topography we will have to define. So how it is defined? Topo is what? A new topography. It is a flat grid type. Means it is a plane, flat plane of what dimensions? Value of x and value of y. Okay. And what is the value of x? Value of x is 5000. And what is the value of y? Value of y is again 5000. So this is a flat grid of 5000 cross 5000 size. Okay, in meters. 5000 meter cross 5000 meter means, or 5 kilometer by 5 kilometer. So this is up to here we have created the flat grid. Okay. Now compare it again with wired scenario. These two lines we used there for creation of trace file, and these two lines we used there for creation of network animator file. Okay. However, this line is in here. I will comment it for now. When I will run this program, I will tell you why this line is used. So currently focus on these 4 lines only. So trace FD open wireless underscore out dot tr in write mode. Obviously you can understand it. Trace FD is a variable that contains a file named wireless underscore out dot tr in write mode. Okay. Now this command you know already, trace all in trace FD. Okay. So in wireless out dot tr everything, every event is written. Okay. Now set nam trace. Again this is a variable name, you can change it to anything. Open wireless underscore out dot nam in write mode. So this file is opened and everything will be written in it. But this line is slightly different from the wired scenario. How? Instead of this nam trace all wireless is used. Okay. So this is a command. You should not change it. Again $nam trace It is the variable we have used, and value of x and value of y. Value of x is again the same thing, 5000, and value of y is 5000. Okay. So why we have defined value of x and value of y here? Because network animator should also know the dimensions of your topography. Okay. According to that, it will set its window size. Okay. If you set this value, suppose 10,000 cross 10,000, but your nodes are moving in 5,000 cross 5,000 area, then those will look very small. Okay. So that is why it is kept same as our scenario. Okay. I hope you understand by now everything, because it is just the repetition of yesterday's session. So now one more thing, create God. Okay. So what is this God variable? It is used to define the number of mobile nodes. Since we are using the wireless scenario, the nodes can be mobile as well. Okay. So this God variable, create God, value of nn we have written. Okay. So what is the value of nn? The value of nn is what we have given here, 150. Okay. So 150 is the number of variables, and this number of nodes, 150 is the number of nodes, and these nodes can be mobile. So we have to write the value of nn variable here. Okay. Now you should pay attention to one thing. Whenever we define a variable, okay, here look at this, set value of x 5000 we are defining here. So we are not writing dollar in front of it. Okay. But whenever we are using any variable, here we are using that particular variable, we are writing dollar in front of it. Okay. So whenever we use any variable, we have to write dollar in front of it, and whenever we are declaring a variable, we will have to write nothing. Means no dollar will be there, only the variable name. You can compare it with any instance. Suppose this topo is here and dollar topo is here. ns underscore is written here, dollar ns underscore is written here. Okay. So this is the thing. So we have created the God variable. Okay, the full form of God variable is General Operations Director. Okay, so no need to know its full form. General Operation Director I will write here. Okay, so now let us proceed. We have defined the scenario, and we have defined how many number of mobile nodes will be there. Now we will have to define the nodes, but before defining the node, the properties of that particular node we will have to define. Okay. So global node setting is here. This is a fixed set of lines. You should always copy and paste it anywhere if you want. Okay. Only the values you can change according to your scenario. How you will change the value, I will tell you. First understand this line, ns underscore node config ad hoc routing. Okay. What is the routing type? It is defined as dollar value of routing, and dollar value of routing is what? We have defined it at the top. Value of routing is AODV. So we are assigning this node that it will work using the AODV routing protocol. Okay. We can write directly AODV here. There is no need to assign any variable above. Okay, for it. We can directly write AODV. But I will not suggest you this thing. Why? Because TCL is very sensitive script. Even if some space or something will be there, it will show some error. Okay, especially in this part. So, and you won't be able to identify what the error is because you can't see a space. So, I will always suggest you to just copy and paste these lines and change the values at the top. Okay, don't touch these lines. So now value of routing is AODV as we have shown here, as we have defined here. LL is written link layer type because it is always same. It is written here like LL. Link layer type is LL. LL is link layer only. It is a TCL hook. I will tell you the TCL hook. Value of MAC. Again, what value of MAC we have defined? MAC oblique 802_11. Okay, so wireless LAN. This node will work on the wireless LAN MAC protocol. Okay, IFQ type. Which type of queuing we are using? $Q type. $Q type means Q type we have assigned here queue drop tail priority key. So this type of queuing this particular node will use. Antenna type, same thing, it is repeated. Antenna type omnidirectional we have defined above. Propagation type, value of propagation we have defined two-ray ground. Physical layer type again we have defined as wireless physical layer. Channel type is wireless channel. Topo instance is topography. Okay. So all of these things we have defined above and we are using these variables here. Okay. Now these three lines are for trace file. You don't touch it. You may turn it on but don't turn anything off. Okay. Otherwise no need to touch it. Now the last three lines I have added for you to understand the energy. How to add the energy model. Okay. So energy model, for adding the energy model you will have to paste these four lines. Energy model is the energy. This is again the keyword. Okay. There may be other energy models also as the researchers are proposing, but we are using the basic one. I don't know which energy model actually it is because there are many types of models are there, but I have written it here. So now what is some values of this energy model we will have to define. So what it is? Transmission power, receiving power and initial energy of a particular node. Suppose a particular node is defined, how much power it consumes in transmitting a particular packet. Okay, a particular packet, or in 1 second how much power it uses, how much energy it uses, that we need to define. And initial energy we will have to define too. So I will tell you why this 0.3 is written, why 0.6 is written, and why here 1 is written. What is the meaning of it? So first understand initial energy. Initial energy 1 means the energy is 1 joule. Okay, the energy of the pack, this one is energy of the particular node that we are going to create is 1 joule. 0.6 means if the transmitter works continuously. Okay, so it will consume 0.6 joules. Okay, so the power consumption of this transmitter is 0.6 watts. Okay, up to 1 second if it works continuously, then it will consume 0.6 joules, and if it receives continuously up to 1 second, it will consume 0.3 joules. Okay, and the total energy is 1 joule. Okay, so there is not much energy we have assigned initially. Only 1 joule is not sufficient. The nodes may die very early. Okay, so I have created it knowingly. Why? So that you can see how the energy is represented in the simulator, in the network animation. Okay, so now up to here what we have done, we have created the properties of node. Okay, what type of property node means node will have what type of properties. Okay, so but we have not assigned the nodes yet. Okay, so now whatever node means, if we assign 5 nodes, we assign 10 nodes now, then those nodes will be having this property. Okay, but if we want to assign a different type of node or a group of different type of node, then what we will have to do? We will have to copy these lines and paste it when this type of nodes are created. Paste it later somewhere. Suppose here I am pasting it, and create more nodes here by changing these values. Okay, so you will be able to create another type of network. Okay, so the different types of nodes you will be able to create. Okay, these nodes might be using some different MAC layer protocol or routing layer protocol. That is up to you. Okay, but for today's session I won't be doing this. You can do it on your own. Okay, now one important thing is defining the node. Yesterday we defined the node very easily. Why? Because we defined only 4 nodes. So for defining the 4 nodes, we can just copy paste the simple command ns set ns node. Like this we can create 5 to 6 or 10 nodes very easily. But suppose you want to create 150 number of nodes, as we are creating in this scenario, we cannot define those nodes manually. Okay, means suppose 150 lines we cannot write. Suppose we have to change something in a node, we will have to change all the lines. So it is not feasible actually. So that is why the loop is created in every programming language. There is a thing called loop. You all already know that, I hope. Loop is to repeat a particular set of tasks until a condition is reached. Okay, so let us see how we have created the nodes. These lines create node. First line is initialization of loop. For set I 0, I will write the corresponding C code with a comment. For I is equals to 0, I is less than value of nn and I plus plus. I hope all of you know C or C plus plus at least. So if you can understand this line, this is the initialization of for loop. It means what? I will start from 0 and it will run the loop until I is less than value of nn and I will be incremented by 1 every time. Okay, so now what we can do? We can convert this code into the TCL script. Okay, in TCL script the same thing is used for set I 0. Okay, now in brackets value of I is less than value of nn and then increment I. All 3 sets are used. I is equal to 0 corresponds to this. I is less than value of nn corresponds to this. I plus plus corresponds to this. Okay, so this is the initialization of the for loop. Now let us see how we are defining nodes here. So I will start from 0 and I will go up to what value, which is less than value of nn. So what is the value of NN we defined here? 150. So I will go up to 149 value. Okay. Now when we are running this loop first time, the value of I will be 0. Okay, so let us see how this code will work. What is written inside this for loop? Set node underscore I. Okay, ns node. This command you already remember. Set n0 ns node we used yesterday. Today we are using set node underscore $I. Why we are using this? Because this $I will be changed every time the loop runs. Okay, when the loop is running first time, so node 0 will be created. Node underscore 0 ns node. Okay. So a node will be created which has the name node underscore 0. Okay. So I will run all the steps one by one. Now, what is next? Set x integer rand into 5000. Okay, I have wrote this line knowingly so that you can understand some basic things of PCL. First thing is you should remember, or you may not get at once, means some of you might not get at once, but you can see the recording for it. Whenever you define a equation, whenever you define an equation, suppose in C++, how you write? Suppose y is equals to mx plus c. It is a simple equation for line, but you cannot write it directly in PCL. Okay. So what we have to do? This expression expr we have to use. Okay. If we want to write an equation, set x is what? X is equals to. Okay, set x means x is equals to, I have already told you many times in this script. Set x means we are defining one variable named x which is equal to what? This one. So this is what? An equation. expr. expr is what? It is the integer value of rand into 5000. expr means nothing. expr just says that some equation is above. This means some equation is defined after it. Okay. So here, this is the equation that is defined inside the expr. So what this equation shows? It is the integer value of a random variable multiplied by 5000. Okay. Random variable RAND creates a random variable between 0 and 1. Okay. So, and our scenario size is 5000. That is why I have written 5000 here. So, a random variable is generated between 0 and 1. So, suppose 0.5 is generated. So, 0.5 into 5000 is what? 2500. So, 2500 will be the value of x. Okay. This int is written so that the value is converted into integer. Okay. Suppose we have in points we have got something, suppose 25.4. So it will be converted into 25 using this command. Okay. So these basic commands I have used here. However, you can delete this command. There will be no issue in that. Okay. But some value you will have to provide to create x. Okay. Now, in the similar way, y we have created. Y is what? Again, a random value multiplied by 5000 and its integer coefficient, means integer part. Okay. So, x and y, two variables are created. Now, what we will do with these variables? We are creating a wireless network. So in that network, the node will be having some position in the topography. Okay, so that position I am defining by these two lines. Okay, these two lines defines what position will be there and these two lines actually transfer the values we have just created to the what? To the node. Okay, so this is the command node underscore $i. It is what the node has. This is the name of node, this one, if you remember. This is the name of the node. Set x underscore $x. Okay, x underscore is what? It is a command, you should not change it. X underscore means x underscore, you cannot make it small or you cannot remove the underscore. Okay, and this is what? X, this value. So node 0 will be having a x value of whatever is generated here. Okay, in the similar way, node 0 will be having y value which is generated using this line. And the similar way, the z value is defined. Okay, the z value is what? 0.0. Okay, so it is the size of the antenna actually, means the at what place the antenna is situated. Okay, so we are assuming antenna is at the ground. Now set x, again we are repeating the same lines. Why we are repeating the same lines? These lines, if you see, we have repeated here. Again it will generate two random values for x and y. But why we are generating now? We have already assigned the values for x and y of that particular node. So these values we are generating for the destination position. Okay, initial position only we have defined yet, but the final position we have not defined. Since these nodes are mobile nodes, so when the nodes are moving, in which direction it will move and by which velocity it will move. So these things we will have to define too. So these two lines define what? The final destination position of that particular node. And this line defines what? The speed of the node. Okay, by which speed the node will move. Okay, so here I have multiplied it by 50 because it is in meter per second. So 50 meters per second is enough velocity. So V will be anything between 0 to 50 meter per second. Okay, now what will happen now? These are three values we have declared only, but we have not assigned to the node. How we will assign to the node? Using this. So ns underscore at 1.0 and some commands are written here. What this command is? ns at 1. Okay, this command is used for if we want to run a particular command at a particular simulation time. ns at 1 means at 1 second this command will run. Okay, so at 1 second node underscore I means node 0, set dash means set dash, it is a keyword, you won't have to change it. Destination we are setting, x value means this value whatever it is generated, y value this one whatever is generated, v value this one whatever is generated. So x, y and v three values are generated using these three variables, and it is assigned to the node using this command. Okay, so at 1 second of the simulation time, the node 0 will start moving towards this direction x comma y with a velocity of this. Okay, yes, velocity may change with time, but for that we will have to write. Suppose for instance you want to change this node's velocity after some time. Suppose at 1 second it has started moving towards this value at the velocity of this. So what you will have to do? Copy and paste this line. Suppose at 10 seconds you want to change its velocity. Okay. So what you will have to do? You will have to paste this line here, and this value of V you will have to redefine. Okay. You will have to again define the value of V. Okay. I hope you understand this. We have defined another, this one more value to V we have assigned, and this V we are using again here. The X and Y we have assigned whatever we have defined previously. So only the velocity will change at the 10th second and not the direction of the node. If we want to, we are assigning dynamically only the position, but if you want to put manually, you can put. However, if you are putting manually, then it will take a lot of time, as well as if you want to change the it to some other thing, you will have to change all the lines in the node. Suppose you are having 100 nodes or 150 nodes, then it will take a lot of time. That is why we assign it dynamically. Okay. In this scenario, I am defining random. Everything is random. Means the node's position, initial position, final position. As much time as you will run the scenario, the position and the direction and the velocity will be different. Okay. So what you can do, as you will move further and start working something, you can define a static scenario using the loop as well. Okay. By using this is, I have generated a random variable here. But instead of this random variable, you can define an equation. Okay, you can think of that. Okay. Now paste this line here. Okay. Now what you can do? Some of you might not be getting it. I will tell you what I have done. What I have done now, I have created another loop in this loop. Okay. So what it does, at first second, we can remove this line as well. Okay. I have commented it because I will be changing it to the previous one only after you understand it. What I have done, I have created one loop. Okay. A loop is created, set I1 0, I1 is less than 50. Okay, I have assumed any value 50 and INCR I1. I1 will be increased one by one. Okay, so the same value I1 I have used here as well, and here we will have to use like this. Okay, and value of I1 I have used here as well. So what is this code shows that the node 0 or any node will be at the 0 second, it will have the speed 0. At first second, it will be start moving at the speed 1 meter per second. At second 2, it will start moving at 2 meter per second, like this, up to 50. Okay, by 50 second, it will start moving at 50 meter per second. So like this we can do. So this is a very simple example I have given you, but you can create anything. If you can write an equation here for that. Okay. So like this you can create. There is no problem in that. So I will move it. I will undo everything and keep it as the previous it was. Okay. So now I will remove this one also, because all of you might have understood. Okay. So now what we will do? Up to here I think everybody got it. Now what will, okay, so this loop, after it has reached here, it will go to the first line again. It will increment I. I value will be what? 1 now. So node underscore 1 will be created now, and what it will do? Again it will, a random position is assigned to it, and again the random destination is assigned to it with a random velocity. Okay. So this is what? This is the code for assigning nodes and their positions, and initial positions and final position, as well as their velocity. Rand function produces an fraction value between 0 and 1, means a decimal value, 0.000112 to 0.99999 something. Okay, it generates it. It may be generating 0 or 1 as well, but I don't know because I have never seen it generating that. Okay, so 0 and 1 up to it will generate, and we are multiplying it by 5000. Why? Because our scenario is 5000. So suppose 0.75 value is generated, so it will be multiplied by 5000 and the value will be 3750. Okay, so like this we will have to do. Okay, now what we have done yet, we have created the nodes only, and we have assigned the protocols. But what protocols we have assigned it, you look at it carefully. The routing protocol we have assigned, MAC layer protocol, link layer protocol, and physical layer. Okay, so first 3 layers protocols we have assigned: physical layer, network layer, and medium access control layer, and link layer. Means both are same, data link layer. So these layers I have defined, but not the application layer and the transport layer. Okay, so we will have to define it now. I have changed this code to, earlier it was of CVR and UDP, but for yesterday you had some doubt about TCP, so I have converted this code into the TCP. Okay, so today we will be understanding this code with TCP. No differences in that. Okay, it works same. Now set. Okay, now we will do what? We will attach TCP agent to nodes, and some sync we will assign to another node, and will connect both the nodes. How we will connect? Means this node will be transmitting to that node only. Okay, so this is some program I have written for that. Let us see how this program works. You can write it in any manner. Okay, so after this webinar, you should create your random scenario. What do you think about a scenario that I have to create this scenario and try to generate it using for loop, different variables, because this is the foundation of your learning. If you don't understand these things, then you won't be able to understand the source codes efficiently. Okay. However, once you are very much comfortable with TCL files, then you will not have to change it, because every scenario you have created one standard scenario for your particular research area. You can create everything on it. Okay, means you can check all your protocols and on that particular scenario. Okay, in my PhD also I created only one scenario, and on that scenario I simulated all the protocols. Okay, so it will be very easy for you, but you will have to understand it, otherwise you won't be able to understand the source code. Okay, so let us see what this code says. For set I0, I is less than 50, increment I. Again the same thing, I will be initialized by 0, I will be less than 50. Okay, then increment I. So I have defined a value 50 here. Why? Because I am assigning only 50 receivers. Okay. Sorry, 50 transmitters. 0 to 49. Okay. Since the transmitters are 50, the receivers also I have assigned 50. But however, you can assign the less amount of receivers as well. Suppose you can assign only 5 receivers. So all the 50 agents will be transferring data to any one of those 5 receivers. But I have assigned 50 receivers as 50 transmitters. Now let us see how I have defined. I have defined using this command. It is the same thing. So TCP underscore 0 will be created, which is what? A TCP agent, and it will be attached to a particular node. Okay. So set A, again I have done what? I am attaching this particular TCP agent to a particular node. But for attaching it, what we will have to do? Select a particular node. And how we are selecting a particular node? I am selecting it randomly. Okay. So I have defined a random variable A that will generate a value between 0 to 148. Okay. 0 to 148 it will randomly generate any value, and node underscore $A means whatever value is generated. Suppose 5 is generated. So fifth node will be attached to what? TCP underscore $I. Means TCP 0 will be attached with node 5. Okay, try to understand it. I am knowingly created it a little bit complex because this is the only scenario we have to read it today. We have to understand it. So along with this scenario, I want to tell you the many concepts as well. So I have declared a random variable, random integer between 0 and 148, and assigning this random variable to a node means, and a node will be selected based on this random variable. Suppose random variable is generated 15, so node 15 will be selected and it will be attached with TCP 0. Okay. Okay. Okay, with a diagram. Actually, I have no diagram yet, and if I start drawing it, then it will be problematic. Okay, okay, wait a minute. I will do what? I will open the okay, suppose this is the scenario. What I am doing, total number of nodes are 150 in our scenario. Okay. So what I am doing, I am creating, see this, I am creating a TCP agent, TCP 0. Okay. That TCP 0 means initially we are creating TCP 0. TCP 0 will be attached to any of the node. Okay. So what node, to which node it will be connected? That I am assigning randomly. Okay. So TCP 0 will be attached to any particular node. Okay. This is a simple programming concept. You understand it. Set A. A is a random variable between 0 to 148. Okay. I am writing A inside this node. Means I have created 0 to 149 nodes. Okay, total 150 nodes. So any random node will be selected and it will be attached to this TCP agent, TCP 0 that we have just created. Okay, so if this is your node, suppose it has selected 149. So 149 it cannot select because I have given up to 148 only. So if it is selecting suppose 81. So AD 81 will be attached with TCP 0. Okay. It is like this, but I cannot show you attached TCP agent here because it is not visible in it. Okay, so this is it. When the next iteration of this loop starts, TCP1 will be created and again a random number will be generated and it will be attached to that particular random node. Okay, TCP will be attached to a particular random node. Means I am just creating a TCP agent, TCP0, TCP1, TCP2, and every agent is attached to a random node. Okay, it is this much only. Now, set sync underscore $I. I told you yesterday when we are using TCP, we will be using sync. Okay, so sync variable I have used here and the agent is TCP sync. Okay. So again the TCP sync I have created, that I will connect to what? For simplicity, I have connected it to the node A+1. Okay, now you will think what is A+1? As I told you, suppose first TCP agent is attached to 81. Okay, so 81 is transmitting. So I have done what? 82 will be the receiving node. A means 81 plus 1. 82 will be the receiving node. Okay. Wherever it is in the scenario, it is a big scenario, so it is difficult to locate it. So wherever is the 82, the 81 will be trying to transmit data to 82 only. Okay. So I have created like this. So how I have written this? Understand it, ns underscore attach agent node underscore expr $A+1. Okay. I told you to write, if we are writing any equation, means I am writing A+1. So we will have to keep it inside an expr bracket. Okay. So expression is what? A+1. So node underscore expr A+1. So 81 plus 1, 82, and the sync will be what? Sync will be 0 only. Okay, sync 0 is attached to node number 82. Okay, so I have attached TCP agent to node number 81 and TCP sync to node number 82. Now, again the next thing, I have created the transport layer protocol but not the application layer protocol. So application layer protocol along with TCP generally use FTP. Okay, file transfer protocol, because it requires the proper transmission. The packet drops are not allowed in it. Okay, so FTP requires the successful data transmission. Okay, so how I am defining it? Set FTP underscore 0. Again, FTP 0 is a variable. This is a variable. New application FTP. Application FTP means this is a command. If you want to create an FTP agent or FTP source, you will have to create this command. Means paste this command and assign it any variable. Now in this line, FTP agent is attached to TCP agent. Okay. So FTP 0 is attached to TCP 0 and TCP 0 was attached to node 81. Now what happened? Application layer protocol as well as transport layer protocol of node 81 is defined. Okay. Now, and it is also defined for TCP sync is for node number 82. Okay. Now I have defined the source, the receiver, but we have not connected yet. Suppose there are 50 source, 50 receivers. Which source will transmit to which receiver, that we have not defined yet. So how we will define it? Using this line. NS connect TCP 0 to sync 0. TCP 0 is attached to sync 0. Okay. So node 81 is connected to node 82 because TCP0 is attached to node 81 and sync0 is attached to node 82. Okay. Now the next line is we will start the transmission of data and stop. It means what? At 5th second we are starting the transmission of data. Yesterday we gave the command with respect to CVR. We did CVR start, CVR stop at particular second. Similar way is for FTP too. So FTP is starting the data transmission at 5th millisecond, 5th second. Okay, FTP0 is starting and FTP0 is stopping the data transmission at 150 millisecond, at 150 seconds. Okay, so it will keep on transmitting the data up to 5 to 150 milliseconds, 150 seconds, sorry. Now I have shown you the loop for first iteration only, for when the value of I is 0. When the loop repeats, means in the second iteration the value of I will be 1. So TCP1 will be created. It will be now attached to a random node again, suppose 51, and what will happen? It will be attached to a sync. Okay, and sync will be what? If the 51 node number is selected, the 52 will be the sync. Okay, so like this I have created this scenario. So when I will show you the scenario in simulator, you will understand how it is working. Now, okay, now the just formality is remaining. These lines, whenever you are defining a mobile node, this line you will have to provide. Okay, what this line shows, you just copy paste it in any of your code and put your node name here, the maximum number of nodes here, and this is the radius. Suppose 50 is written here, it represents a radius. If we write suppose 100, the radius is something else. So like this you can change it. If you want to see nodes large, you can make it 500 or 100 like this. Now these lines are nothing but to reset all the nodes. Means you have to paste these lines in all your codes. Okay, all the wireless scenarios you will have to paste these lines. Why? Because to stop the nodes. Okay, reset the nodes. If you want to select a cluster head using TCL file, then it will be fixed. Okay, you can select the cluster head. Suppose you want to fix with a cluster head with a TCL file, then you will have to provide which will be the cluster head for what time. Okay, but in generally it does not happen. We only define the cluster head using some properties of that node. In the scenario, when the scenario is running, simulation is running, then only we can define. So the cluster head is defined using the source codes only. Okay, because we will have to check some properties of that particular node in runtime. Okay, so now these lines are for NS at value of stop. Value of stop is what? 200. Okay, at the top I have assigned it 200 second. What will be there? Node will reset. Node 0 will reset, then node 1, node 2, all the nodes will be reset because this is a loop. Now this is again a formality. You will have to write it. NS at value stop. At this particular value, these lines will be printed. Okay, if you don't write this thing, no problem will be there, but it will be an indication that your program is stopping. Put starting simulation NS run. Okay, NS run is always you have to give command at the end, and this line I have attached. Why? Because you can see the NAM file after the simulation is over. Okay, if you delete this file from here, then there will be no problem. So now I will tell you in the next webinar, means on 5 to 6, how we can proceed to learn anything. Because if you want to learn NS2, you should not learn something. You should not learn that how you will learn a new thing. Okay. How you can learn new things, that you should learn. Even I don't know many things in NS2. Suppose I have worked on vehicular networks and a little bit of sensor networks, and somebody if says that you should work on suppose servicing IPv6. So I have no idea about it. But I know the basic files. Where can it be located? I can search it, and if I know the theory of mobile IPv6 very well, then there will be no problem with me to understand it. Okay. So the theory learning is very necessary. After that, the basic knowledge of NS2, what are the basic files and how we will proceed to find any source code, that is necessary. Okay. So that is how you can proceed. In the next webinar, I will tell you regarding the source codes. Okay, today also I will tell you a little bit, but not much because of the time limitation. In a loop, in a for loop, next line, set node, ns node. In a for loop, where? Yes. Okay, it is nothing but if you remember the wired scenario, we created what? I will write here set n0 ns node. Okay, this is what the command we provided in wired scenario. Okay, this is the same command as this one. What is the difference? Only the variable name is different. Okay, and underscore is written here. Why? Because it is a wireless scenario. So, what will happen? NS node is a command. Actually, you will have to provide it. NS underscore is what? NS underscore is the simulator name. Okay, new simulator is defined as NS underscore. So that is why we have provided NS underscore here. Where it is? Okay, here. So NS underscore is your simulator object, and this is the command simulator object. And if you write node here, then a node will be created with a variable name this. Okay, the same thing is here. I hope you understand it. So now, okay, this is over. Everything is over.